Hey mathematicians, Justin here with a challenge for you. Can you name the shape I'm thinking of? I'm thinking of a shape that's perfectly symmetrical, has no flat surfaces, has no corners, and no matter how you turn it, it looks the same from every direction. Oh, and it's also the shape of the candy I'm making today. Super Sour Blasts. Any guesses? Let me give you another hint. Think marbles, peas, and my basketball. Did you figure it out? I was talking about spheres. The Super Sour Blasts are spherical candies, which means they are perfectly round, three-dimensional shapes. Spheres also occur in nature too, which is pretty amazing considering they're such unique shapes. What's an example of a sphere in nature? Write down your ideas. I thought of bubbles, fish eggs, and oranges. Keep an eye out. Spheres are all around you. Okay, back to work. Today at the Circleville Candy Company, I'm helping make super sour blasts. And I got the fun part, putting on the super sour coating. I just need to figure out how much coating I'll need. Since the sour coating covers the outside of the blast, will I need to calculate surface area or volume? Write down your answer and reasoning now. Yes, I need the surface area formula because the coating goes on the exterior of each candy. Usually when calculating surface area, we start by finding the net of the 3D shape. Well, how many faces does a sphere have? It's one curved surface. Since a sphere is made up entirely of curves, it's not possible to create a flat 2D net that would represent the entire surface area of one. That means mathematicians had to use a different method to figure out the formula for the surface area of a sphere. Curious what that is? After the video, check out the bonus activity called Formula Discovery to learn more. Anyway, these brilliant mathematicians did figure out the formula for the surface area of a sphere. It's A equals 4 pi r squared, where r is the radius of the sphere. Said in words, the surface area is 4 times pi times the radius raised to the second power. The radius of a sphere is the distance from its exact center to any point on its surface. For example, the radius of my basketball would be the distance from the exact middle, where the air is, to the outer surface of the ball. Let's practice applying that formula to find the surface area of a couple of spheres, then we'll be ready to coat our super sour blasts. What's the surface area of this sphere in terms of numeric units? Here's our formula for the surface area of a sphere. What variable or variables will I have to replace in order to use this formula? Highlight or circle them in your notes. R is the only variable in this formula, so the only unknown information I need is the radius. Underline the radius in the diagram. Yep, the radius is 5 inches. Substituting that, we have 4 pi times 5 squared. Should I evaluate this using the pi symbol, or should I substitute in 3.14? Yeah, the problem asked for an answer in numeric units, so we'd better substitute 3.14 in place of the pi symbol. Now, using gems, 5 times 5 becomes 25, so our next line is A equals 4 times 3.14 times 25. Multiplying that together from left to right, 4 times 3.14 is 12.56, and then 12.56 times 25 leads us to the final answer, 314. What's our unit? Inches squared, right. Since surface area is two-dimensional, area units are always squared. For this next one, we have a big ol' sphere. This problem says calculate the surface area in terms of pi. To get started, underline the radius and substitute it into the formula. Wait, what measurement are we given this time? That line on the sphere goes all the way from one side to the other through the center. That's a diameter. The diameters in radii in spheres have the same relationship as they do in circles. Try it yourself now. Use the diameter to calculate the radius of this sphere. Right, the radius is half the diameter. So we take the diameter, 32, and divide it in half, which means dividing by 2. 32 divided by 2 is 16, our radius. All right, now you take it from here. Use this measurement to calculate the surface area of the sphere. I started by writing out the formula, a equals 4 pi r squared, and then substituting 16 in place of r. That gave me a equals 4 pi times 16 squared. Okay, should I keep the pi symbol or substitute 3.14 in place of it this time? Since we want our answer in terms of pi units, we don't substitute 3.14 in place of pi. That pi symbol needs to be in your final answer, so don't get rid of it. Next, I simplified the exponent. 16 squared is 256, so now it's a equals 4 times pi times 256. Since multiplication is commutative, we can multiply our whole numbers together, skipping over the pi symbol. That gets us 1024, and remember we put the pi symbol after the number, so our final answer is 1024 pi square meters. All right, fellow mathematicians, time to do it for the candy company. I've got to figure out the surface area of a super sour blast. Each candy has a diameter of 1.2 centimeters. How much sour coating will it take to cover one super sour blast? First, should we get our answer in terms of pi or numeric units? What would be most helpful? Write down your answer and your reason. I'm going to solve this in terms of numeric units since this is a real-world scenario and we don't usually measure in terms of pi. So let's round our final answers to the nearest 10th in that case. Pause the video here, solve this problem, and then we'll compare our answers. All right, what's the first step? We need to get our radius right. The formula is a equals 4 times pi times r squared, so we need our radius to substitute in place of r. Since we know the diameter, how do I figure out the radius? I divide the diameter in half to get that radius. 1.2 divided by 2 is 0.6, which means our radius is 0.6 centimeters. Now that we know our radius, what do we do with it? We substitute it into our equation in place of r, like this. Next up, it's time to decide about pi. Substitute 3.14 or no? We agreed to solve in numeric units, so that means substitute. So our next line is a equals 4 times 3.14 times 0.6 squared. Next, evaluate the exponent. 0.6 times 0.6 is 0.36. And now we multiply from left to right. 4 times 3.14 is 12.56, which we then multiply by 0.36 to get 4.5216. Rounding to the nearest tenth, we get 4.5 centimeters squared, which means there's 4.5 square centimeters that need to be coated with sour powder coating. Now, I have to figure out how much I'll need for a whole batch of super sour blasts. If you want to help with that, see the bonus question at the end of the notes. Aren't spheres cool? From sour candies to soccer balls, bubbles to fish eggs, spheres are all around you. And the surface area goes all around the one curved face of the sphere. We figured out the formula only requires one measurement, radius, and the formula is a equals 4 pi r squared. While you're thinking about it, don't forget to add it to your formula reference sheet. Be sure to finish out the guided notes and work on practice levels 1 and 2. Thanks for your help today. Until next time, keep questioning, keep calculating, and remember, studying math will keep you well-rounded. See you next time.
Hey, hey.